Hello, I am Sunita. Welcome to my class. Here I am going to discuss JPSTR science topics according to the syllabus. Here the topic is thermodynamics. In this one, let us study about in detail basic concept of thermodynamics, thermodynamic system, thermodynamic processes, thermodynamics properties. Let us start the class. Let us discuss in detail what is thermodynamics. Thermodynamics deals with the concept of heat and temperature. Thermodynamics mainly it will based on the concept of heat and temperature and interconversion of heat and other forms of energy. You know, heat is a form of energy. Then heat you can convert from one form to another form. The four laws of thermodynamics govern the behavior of these quantities and provide a quantitative description. The thermodynamics it contains four laws. That four laws it will tells the behavior of these quantities like heat and temperature and their interconversion of energy from one form to another form and provide a quantitative description. William Thomson in 1749 coined the term thermodynamics. He is the scientist who discovered the topic thermodynamics. Then let us discuss the definition of thermodynamics. Thermodynamics in physics is a branch that deals with heat, work, temperature. Mainly it deals with the concept of heat, work, temperature and their relation to energy, radiation and physical property of matter. How heat, work, temperature, how they are related to energy. Then how you can convert from one form to another form. Then radiations and also physical properties of matter. Physical properties of matter is nothing but whether the matter is solid or liquid or gaseous state. Then it will decide the melting point and boiling point of a particular matter. Then also it will gives the external appearance of the matter. Physical properties of matter is nothing but the external appearance of the matter. To be specific, it explains how thermal energy is converted to or from other form of energy and how matter is affected by this process. Then thermodynamics mainly it will explain about heat and temperature, already I told. Then it will explains in detail how the thermal energy is converted from one form to another form. Then after conversion, how the matter it will affect by this process. Matter is nothing but which has mass and occupies space. Then matter is made up of a particles. Then after converting the energy from one form to another form, then the movement of the particles, then arrangement of the particles inside the matter it will change. Then this changes it will explain by thermodynamics. Thermal energy is the energy that comes from heat. Thermal energy it is coming from the heat. This heat is generated by the movement of tiny particles within an object. How the heat it will generated means when you provide the heat, then the particles inside the object they will start moving. Then because of the movement of the particles, it will generate the heat. Then faster these particles move, the more heat is generated. When the particles they will move faster, then the kinetic energy of the particles it will be increases, then more heat will be generated. Therefore you have to remember, when you provide a heat, then thermal energy of the matter it will be increases. Then when thermal energy increases, then movement of the particles inside the object it will be increases. Then thermodynamics is not concerned about how at what the rate these energy transformation are carried out. Thermodynamics mainly it will not explain whether the reaction, otherwise how the conversion of energy from one form to another form it will take place. It will not explain the rate of the transformation. It is based on the initial and final status undergoing the change. Then already you know three different status. One is solid, liquid state and solid, liquid, gaseous state. Then here thermodynamics it will be mainly based on the initial and final state that undergo the change. It also be noted that thermodynamics is a macroscopic science. You know, thermodynamics is a macroscopic science. This means that it deals with the bulk system, does not deal with the molecular constitution of a matter. Always thermodynamics, it is dealing with the bulk system. It will not deal with the molecular constitution of matter. Molecular constitution of matter means which type of particles that it will constitute a matter. The type of a particle, it will not matter. Thermodynamics, it will deals with a bulk system. That one you have to remember. Basic concept of thermodynamics, thermodynamic terms. First one, system. A system is a region containing energy and matter that is separated from its surroundings by arbitrarily imposed walls or boundaries. Consider this is a system. This is a region containing both energy and matter. Then this system is separated by a system boundary. Then it will separate the system boundary, it will separate system from surrounding. Then this system boundary, it is indicated by a dark thick line, you can observe here. Then this system, it is a region, it contains both energy and matter. Then next one, system boundary. A boundary is a closed surface surrounding a system through which energy and mass may enter the system or leave the system. Then this is the system boundary. This is the closed surface surrounding a system. Then here you can observe energy and mass from the surrounding, it can enter into the system, otherwise it can leave the system. Then next one, surroundings, everything that interact with the system. Then this is the surrounding, it is indicated by a dotted line, a dotted circle. Then surrounding, it is nothing but everything that interacts with the system. That one we will call it as a surrounding. Then consider an example here. Consider a beaker filled with water. Then here the water, it will indicate a system because it is a region, it containing both energy and mass. Then this is the system boundary because it will separate system from its surrounding. Then this is the surrounding, everything that interact with the system, that one we will call it as a surrounding. Thermodynamic systems. You know, thermodynamics means study of effect of work, heat, energy on a system. Thermodynamics is nothing but study of effect of work, heat and energy on a system. System is nothing but region under the study which is separated by a boundary. That boundary may be real or imagined. Here this one we will call it as a system. That is the region under the study which is separated by a boundary. Then here work, heat, matter can go either the way across the boundary. Then here work, heat, matter can enter the system, it can leave the system also. Here consider this example. This is the round bottom flask. Take water in a round bottom flask and cover the mouth of the flask with a balloon. Then when you start heating the water, then water, it will start converting into a steam. Then that steam is collected in a balloon. Then this full setup we will call it as a system. Then here flask, balloon, water, steam that was heated, everything we will consider all together, we will consider as a system. Then here surroundings are environment outside the system. This one, the environment outside the system, we will call it as a surrounding. Example, maybe if you are doing the experiment in the classroom, then classroom itself is a surrounding. Then here steam does work on the balloon. Here the steam, it will do work on the balloon. When the steam increases, when water is converted into a steam, when steam rises, the size of the balloon, it will increases. Therefore steam does work on the balloon. Steam's internal energy has decreased. Let us discuss in detail about system and types of system. A thermodynamic system is a specific portion of matter with a definite boundary on which our attention is focused. Thermodynamic system, it contains a specific amount of matter, specific portion of matter with a definite boundary which is enclosed in a definite boundary. The system boundary may be real, imaginary, fixed or deformable. The boundary may be real or imaginary, it may be fixed or deformable, means you can change the shape of the boundary. There are three types of system. One is isolated system, second one is closed system, third one is open system. First one, isolated system. An isolated system cannot exchange both energy and mass with its surroundings. The universe is considered as an isolated system. In the universe also, Within the system only the energy, mass and heat it will get transferred. There is no exchange of energy, it will take place around the surroundings. Then here in the case of a isolated system, that it will not exchange any energy, mass or heat with its surrounding. Consider a thermoflask. Thermoflask is the best example of an isolated system, because in the thermoflask normally we will fill hot coffee, tea or hot water. Then this matter, it will not exchange any energy, mass or heat with its surroundings. Therefore this is a best example of an isolated system. Second one is closed system. Across the boundary of a closed system, the transfer of energy takes place, but the transfer of mass does not take place. In the closed system, only the transfer of energy takes place. There is no transfer of mass. Best example for closed system is refrigerator. In the refrigerator, you can observe only the transfer of energy takes place. There is no transfer of mass. Compression of gas in the piston cylinder assembly or the example of closed system. Here simple example, consider a hot water in a beaker, then close the mouth of the beaker with a rubber cork. Then you can observe only the energy of the hot water, it will get exchanged from the surrounding. There is no exchange of mass, it will takes place here. Only the exchange of heat you can observe here there is no exchange of mass, it will takes place. This is a best example of a closed system. Third one, open system. In an open system, the mass and energy both may be transferred between the system and the surrounding. Here you can observe in the open system, both mass, energy and heat also it will get exchanged from system to surrounding. A steam turbine is an example of an open system. Consider a very hot water, hot boiled water in a beaker, otherwise in a bottle. Don't close the mouth of the beaker here. Then here you can observe this water, it will start evaporating, then it will convert it into a steam, then it will mix with the environment. Then here you can observe both the exchange of mass and energy, it will take place. Therefore this is an example of a open system. Surrounding, everything outside the system that has a direct influence on the behavior of the system is known as the surrounding. Everything outside the system, then it has the direct influence on the behavior of the system is known as a surrounding. Interaction of thermodynamic systems. Types of system. First one is isolated system. In isolated system, there is no flow of mass and work and heat, it will takes place. Then in the case of a open system, then you can observe a exchange of mass, work and heat, it will be takes place. In the case of a closed system, only the exchange of work and heat takes place. There is no exchange of mass. Thermodynamic process. A system undergo a thermodynamic process when there is some energetic change within the system that is associated with change in pressure, volume and internal energy. Thermodynamic process is nothing but a system undergo a certain thermodynamic process. When there is some energetic changes, it may occur within the system. The energetic change may be change in pressure, change in volume, change in internal energy. There are four types of thermodynamic process that have their unique properties, and they are: first one is adiabatic process, second one is isochoric process, third one is isobaric process, fourth one is isothermal process. To understand the thermodynamic process in detail, let us consider a piston. A piston is a moving disc enclosed in a cylinder. Piston is nothing but a moving disc that it should be enclosed inside a cylinder, which is made up of a gas tight by piston rings, that is made up of a gas tight by piston rings. Then the disc moves inside the cylinder as a liquid or gas inside the cylinder expand and contract. You can observe the movement of this disc when the gas or liquid, when it is expand or contract, then this it will moves up and down. Let us consider the first case, expansion. Then here this piston aids in the transformation of heat energy into mechanical work or mechanical work into heat energy. Then let us consider first case, that is expansion. Expansion of gas or liquid. Consider here the gas. Then here when the gas when it will absorb the heat, then here the kinetic energy of the particles decreases. Here when the gas when it is absorb the heat, then it will get expand. When it is expand, then kinetic energy of the particle decreases. When kinetic energy decreases, temperature decreases. Here the particles, they are moving far from each other, therefore the pressure decreases. As the particles moving far from each other, the volume of the gas, it will be increases. Then here you have to remember, when the expansion of gas takes place, then it will absorb the heat from the surrounding, then it will get expand. When gas expand, temperature, pressure, it will be decreases because kinetic energy of the particle decreases. Here the volume of the gas, it will be increases. Then work done it will be in this direction. Then consider the second case, compression of the gas. Then here the work done it will be in this direction. When you compress the gas, in then that case it will liberate the heat outside. Then when you compress the gas, then all the particles, they will become closer. When all the particles, when they will come closer, then pressure of the gas, then the temperature of the gas, it will be increases. Then temperature is nothing but kinetic energy of the particles, it will be increases, because when the particle, when they will become closer, then kinetic energy of the particle increases. But here volume, it will be decreases. That one you have to remember. Then work done it will be in this direction. Adiabatic process, a process where no heat transfer into or out of the system occurs. Adiabatic process means there is no transfer of heat inside and outside the system occur. Let us discuss with an example. Example, release of air from a pneumatic tire. In this one, it is a process where there is a gas compression and heat is generated. When you release air from a pneumatic tire, then here the compression of gas, it will takes place. Then here automatically the heat, it will be generated. Then next one, adiabatic efficiency is applied to device such as nozzles, compressors and turbines. One of the good application of the adiabatic process. One of the good application of adiabatic process we will use in the device such as nozzles, compressors and also turbines. The pendulum oscillating in a vertical plane is an example of adiabatic process. The pendulum oscillating in a vertical plane. A quantum harmonic oscillator is also an example of an adiabatic system. The next one, when we put the ice into the ice box, no heat goes out and no heat comes in. This is the very best example of adiabatic process. If you put ice into the ice box, when there is no transfer of heat inside or outside the system, it will takes place. Adiabatic process, no heat exchanged between a system and surrounding. Adiabatic process means there is no exchange of heat, it will take place between system and surrounding. Here consider the piston. When it is compressed, then pressure and temperature increases, then volume decreases. When it is expand, then pressure and temperature decreases, volume increases. That one you have to remember. Next one, isochoric process, a process where no change in volume occurs and the system does no work. Isochoric process means a process, it will involve no change in volume, the system, it will not do any work. These 2 points are very, very important. A good example of an isochoric process is the ideal Otto cycle. In this, when the gasoline air mixture is burned in a car engine, in the car engine we are having gasoline air mixture. If it is burnt inside a car engine, then there is an increase in the temperature and pressure of the gas inside the engine. Meanwhile, the volume of the gas remains exactly the same. In the case of an ideal Otto cycle, Then inside the car engine you are having a mixture of gasoline air mixture. When it is started burning, then it will increase the temperature and pressure of the gas inside the engine, but volume of the gas remains constant. Let us consider this is an example of isochloric process. Here also you can observe when any gas, when it is burns, then it will lead to increase in temperature and pressure, but volume of the gas remain constant, and here you can observe no work is done in the case of a isochloric process. Let us discuss one more example for isochoric process. An example of a nearly isochoric process is a pressure cooker, what we are using in a daily life. When sealed closed, the volume inside cannot change, so when heat is added, both pressure and temperature increases rapidly. Then you can observe in our home we will use to cook rice, we will use a pressure cooker. When you switch on the gas, then you are providing a heat. Because of the heat inside the pressure cooker, pressure and temperature increases, but the volume of the content, otherwise the volume of the matter, it will be remain constant, it will not change, only temperature and pressure increases. Isobaric process, a process in which no change in pressure occur. In this process, isobaric process means, always remember, a process in which no change in pressure occurs, or pressure it will be remain constant. An example of isobaric process include the boiling point of water to steam and freezing point of water to ice. In the process, the gas either expand or contract to maintain the constant pressure. In the case of both the case, like boiling point of water to steam or freezing point of water to ice, when it is converting from water to steam, otherwise if it is freezes from water to ice, then here you can observe the gas, it may be expand or it may be contract, but when it is expand also contract also, it will maintain the constant pressure. Hence the net amount of work is done by the system or on the system. Then here in both the case depends upon the gas whether it will expand or contract, depends on that one. Maybe the work is done by the system or it may be on the system. Then consider this is an example of isobaric process. Then here when you provide the heat, then the gas it will start expanding, therefore the volume of the gas it will be increases. Then here you can observe the masses maintain constant pressure in the cylinder, but the mass it will maintain the constant pressure in the cylinder. Therefore isobaric means a process in which there is no change in pressure occur, pressure it will be remain constant. Next one, isothermal process. In thermodynamics, an isothermal process is a type of thermodynamics process in which the temperature of the system remain constant. Delta T it will be 0. Always remember, isothermal process means, isothermal process is a type of thermodynamic process in which the temperature of the system remains constant. Temperature will be remain constant. Here consider isothermal expansion and isothermal compression. Here when gas expand, here you can observe the increase in the volume. Then maybe pressure also it will change, but temperature it will be remain constant. Then isothermal compression, then volume of the gas it will be decreased, then the pressure also it will change, but the temperature remains constant. Let us consider few examples of isothermal process. First one, change of state or phase, changes of different liquid through the process of melting and evaporation or example of isothermal process. You know we are having three types of status. One is solid, liquid, gaseous. Then if you want to interchange from solid state to liquid state or liquid state to gaseous state or any one of the three status of different liquid, it will involve the process like melting and evaporation. Then all this process it will happen at constant temperature. That is one of the best example of an isothermal process. Then second one of the example of industrial application of isothermal process is the Carnot engine. This one also very important. Industrial application of isothermal process is the Carnot engine. In this engine, some part of the cycle are carried out isothermally. Means in this engine, some part of the cycle it will work on the principle of isothermal. Isothermally means at constant temperature, some part of the engine it will work. Then third one, refrigerator. A refrigerator works isothermally. A set of changes takes place in the mechanism of a refrigerator, but the temperature inside remain constant. You know, inside the refrigerator, a set of changes takes place in the mechanism of a refrigerator. When the refrigerator started working, then the set of changes it will happen. All the changes it will happen at constant temperature. Here the heat energy is removed or transmitted to the surrounding environment. You can observe in the refrigerator the heat energy you can remove, otherwise heat energy is removed or transmitted to the surrounding environment. Otherwise exchange of heat energy it will take place with the surrounding from the refrigerator. Then next example, another example of an isothermal process is heat pump. The heat is either removed from the house or dumped outside. The heat is brought inside the house from outside to warm the house. Here, heat pump is nothing but you can remove heat from the house. Otherwise, you can add heat to the house. In either case, the goal is to keep the house at the desired temperature setting. Either you are removing the heat from the house, otherwise you are adding, otherwise you are providing heat to the house. Both it will involve both the process. The aim of both the process it will be you have to keep the house at constant temperature, at desired temperature setting. If you want to set the temperature of the house, either you can remove the heat from the house, otherwise you can add heat to the house. These are the few examples of isothermal process. A thermodynamic cycle is a process or combination of processes conducted such that initial or final status of the system are the same. It is a process, thermodynamic cycle is a process or combination of processes such that initial and final state of the system it will be remains same. Thermodynamic cycle is also known as cyclic operation or cyclic process. Let us discuss here thermodynamic properties. Thermodynamic properties are defined as characteristic features of a system capable of specifying the system state. Then here thermodynamic properties it will tells the information about the characteristic features of a system, otherwise important features of a system. Then system state, whether the system is solid, liquid or gaseous state, then exactly the system state it will gives. Thermodynamic property may be extensive or intensive. Intensive property means or properties that do not depend on the quantity of matter. Intensive property means it will not depend upon the quantity of matter or amount of matter. It is independent of quantity of matter. For example, pressure and temperature. Pressure and temperature it will be constant for a given matter. If you consider a small amount of matter also, it will be same. If you consider big amount of, otherwise large amount of matter also, pressure and temperature remains constant for a particular matter. Then extensive properties, their value depends on the mass of the system. Extensive property means its value depends upon the mass of the system, otherwise the amount of the system. For example, volume, energy, enthalpy, these are the extensive property. Here volume, energy, enthalpy, it will depends upon the mass of the system. For small amount of mass, volume, energy, enthalpy may be different. For larger amount of mass, volume, energy, enthalpy, that value it will be different. Next one, what is enthalpy? Enthalpy is the measurement of energy in a thermodynamic system. Enthalpy is nothing but measurement of energy, otherwise how much energy the thermodynamic system has, that is measured by enthalpy. The quantity of enthalpy that it will be equal to total heat content of a system. how much enthalpy, otherwise the amount of enthalpy, it will be equal to total heat content of a system. Then here this enthalpy, it will be equivalent to the system internal energy. Then this enthalpy is indicated by capital H. It will be equal to system internal energy plus product of volume and pressure. Mathematically, the enthalpy H, it will be equal to sum of the internal energy E and the product of the pressure and volume V of the system. Then here in the simple word, enthalpy is nothing but measure of energy in a thermodynamic system or total heat content of a system. Then here enthalpy is measured by the equation H, it will be equal to the sum of internal energy of the system plus the product of pressure and volume of the system. Real life application of enthalpy change. The amount of freon evaporated is directly related to the coldness of your food in the fridge. This is one of the great example of enthalpy change. Already you know enthalpy is nothing but measure of energy in a thermodynamic system, otherwise total heat content in a thermodynamic system. Then here you can observe the refrigerator, it will evaporate the freon gas. Then how much freon gas it will evaporate? It will be directly proportional to the coldness of your food in the fridge. Then another great example of enthalpy change. Enthalpy change is hand warmers. As soon as you shake the heat pack, your hand become warmer. When you touch the heat pack, then your hand, it will gains the heat, then your hand, it will feel warm. These are the few example of an enthalpy change. Next one, what is entropy? The entropy is a thermodynamic quantity whose value depends upon the physical state or condition of a system. Entropy is nothing but that is a thermodynamic quantity. That value, it will be depends upon the physical state or condition of a system. Physical state of a system means whether the system is solid, liquid, gaseous. Then condition of a system means in that state, different state, how the particles they will be arranged, that it will depends. In other words, it is a thermodynamic function used to measure the randomness or disorder. Entropy, in the another word, we will used as a thermodynamic function used to measure the randomness or disorder. For example, the enthalpy of a solid where the particles are not free to move is less than the entropy of a gas. Consider the two state, one is solid, another one is gas. You know, in the solid state, all the particles they will be closely arranged to each other. There is no gap between the particles, and the particles they will not at all move. Therefore, entropy it will be less, because entropy is nothing but the randomness or disorder of the particles. A randomness is nothing but how the particles, otherwise the movement of the particles within the system. But in the case of a gas, all the gas particles they will be far from each other, then the distance between the particles it will be more. Then the particles they can easily move inside the gas. Then the randomness of the particles, otherwise disorder of the particles, it will be more. Therefore automatically the enthalpy it will be more, where the particles will fill the container. Then in the case of a gas, if you can fill the gas in a container. This is the main difference between entropy of a solid and also entropy of a gas. Next one, example of entropy. Entropy is a measure of the energy dispersal in the system, otherwise spreading of energy in the system. We see evidence that the universe tends towards highest entropy many places in our lives. A campfire is an example of an entropy. Then ice melting, salt and or sugar dissolving, making popcorn, boiling water for tea, or processes with increasing entropy in your kitchen. Then next one, very important example. What is the best example of entropy? Melting ice makes a perfect example of an entropy. As ice, the individual molecules are fixed and ordered. You know, ice cube is nothing but a solid. In a solid, all the particles they are fixed and also they are orderly arranged. As ice melts, the molecules become free to move, therefore becoming disordered. As the ice start melting into a liquid, then the particles inside the ice they will be packed. Then you can observe the movement of the particle. Otherwise, the distance between the particles it will be increases. As the movement of the particle increases, then particles they will move within the system. Then when the particles start moving, then disorder, otherwise the entropy it will be increases. As the water is then heated to become a gas, ice it will be converted into a liquid. When you heat the liquid water, then it will start converting into a gas. When you provide the heat, then you are providing energy to the particles. Then the particles they will gains kinetic energy. Then movement of the particles it will be more in type of a gas. Then the particles they will be moving very fast to each other. Then entropy, otherwise disorder or randomness of the particles it will be increases. The molecules are then free to move independently through the space. In the case of a gas, the particles they are moving independently and also they are moving randomly. Therefore, in the case of a gas, the entropy it will be increases. Therefore, melting of ice is an best example of an entropy. Thanks for listening my class. Send me your valuable feedback.